Hi guys, so what I have here with me is the Raspberry Pi Zero board. You can easily identify it by the resonating cavity antenna of the Wi-Fi and the Bluetooth. So for long, one of the main advantages of the Raspberry Pi Zero has been its size. So this is a standard wireless mouse. You can see, we all know that how small it has been. It has been so small that you could virtually embed it into any projects. But apart from the size, there has always been a downside to the Raspberry Pi Zero boards, apart from this one. That is the need for cables and adapters for connecting to the internet. Either you needed a adapter like this, which is a standard USB to Ethernet, or you needed a OTG cable for connecting to Wi-Fi. So with this Wi-Fi or wireless chip on board, you can actually do away with all these cables and peripherals, and you can embed this board into almost any project. So the first project which came to my mind is embedding the Raspberry Pi Zero board into a standard speaker and making it a multi-room speaker using Shairport or the Airplay service. So for that, I have here with me a standard Bluetooth speaker, which can also be used as a speaker through the auxiliary port over here. So what we'll be doing is embedding the Raspberry Pi board into this speaker, and also try and you accommodate the Pi hat DAC and get some audio out of it. So in order to get started, first we need to install the OS onto the board, and for this project we'll be making use of the Raspbian JC Lite version. Over to the on-screen instructions now.
So first plug in the SD card into a PC and format it using a SD formatter. So this will remove any pre-installed OSs and also any leftover files. So select your SD card and choose format. Choose OK and OK once more. Once the formatting is done, you can exit this. Open Win32 disk imager. Click on the folder icon over here and choose the Raspbian image and choose write. Choose yes. So once the image is written, choose OK and exit. So by default, you don't have the SSH enabled in the newer versions of the Raspbian OS. So in order to enable the SSH, go into the boot folder, right click, choose new and text document and name it as SSH and delete any extensions. The file should be just named SSH without any extensions. Choose yes. And now you can eject your SD card and plug it into your Raspberry Pi Zero W board and boot it up.
For the first boot, I have connected the Ethernet cable to the Raspberry Pi through the OTG cable. There is also an option of SSHing into the Raspberry Pi through the USB cable connected to a computer. If you prefer to do it that way, you can do it. So once the OS gets loaded, we can enable the Wi-Fi through the SSH, and then we can do away with the adapter.
So after powering on your Raspberry Pi, you can SSH into it. Choose no, login as Pi, Raspberry. Just after your first boot, you need to expand the file system. For that, type sudo raspi config. Scroll down into advanced options and then choose expand file system. choose OK, finish. Would you like to reboot now? No. And as a next step, you need to update and upgrade the OS. So for that, sudo apt-get update. Once the updating is done, you need to upgrade it. Choose yes. And next step is to connect the Raspberry Pi board to the wireless LAN or the Wi-Fi. And last step before rebooting your Raspberry Pi board is to install the DAC, be it the USB DAC or the Pi Hat DAC or whatever. So you need to install the DAC and set it as a default audio device, and then you can reboot your Pi. The DAC that I am using is the Airfruit's speaker bonnet for Raspberry Pi. So I will follow the instructions given in their webpage for the DAC. Say if you are using the USB DAC, the cheap USB DAC from eBay or any other sources, what you can do is you can just modify the asound.conf file and just change the default hardware to number 1. So that should be more than sufficient in your case. In the Airplay setup guide that is attached in the description of this video, you can find the code that you need to paste into the asound.conf file. Once the DAC is installed, you can reboot your Pi. After the reboot, your Pi will connect to the Wi-Fi through the onboard Wi-Fi chip, and as a result, the IP address will change. Now you need to SSH into the Pi using your new IP address. So for this setup, we'll use Mike Brandy's Shairport-Sync. This has been developed based on the Abrasive's Shairport Git page. So the Abrasive's Shairport Git is no longer maintained, and this is evident from his post. And as a result, we'll be using Mike Brandy's Shairport-Sync for our build. And a quick word of thank you to him. I have also created a text file for your reference, which has the various steps which you need to follow for installing the Airplay or the Shairport-Sync. First step is to install the dependencies. So after the dependencies are installed, you need to build and install the Shairport. So as I said earlier, we'll be using Mike Brandy's Shairport-Sync Git. You can just follow the steps in order given in the document. The link for the document can be found as usual in the description of this video. After cloning the Git, you need to change directory. And then you need to choose the configuration. So this auto reconf will take a bit of time. This will vary from board to board, that is between all the Pis. Say suppose if you are using Raspbian VZ instead of the JC, you need to change the system D to system V. So that will be the only change. So under the general settings, under the general, you'll have the name for your Airplay service. So what you need to do is you need to remove the double slashes and assign name whatever you want to call your Airplay Pi as, or the Shairport-Sync Pi as. And then in order to auto start the Shairport-Sync service, open the rc.local and then type Shairport-Sync after the exit, and then press Ctrl X and save. And now after all the processes is done, you can reboot your Pi by giving sudo reboot. After rebooting, we'll verify the Shairport-Sync service and then proceed on to embedding the board into the speaker.
So the Shairport-Sync has been successfully installed onto the Raspberry Pi board. So I thought that a test for the current draw should be made before embedding the board onto the speaker. So instead of using the USB charge doctor, what I have done is I have got a female micro USB port. The positive terminal is directly connected onto the male micro USB, which in turn is connected to the Raspberry Pi 0, and then the ground terminal is being routed through the multimeter through the crocodile or the alligator clips. So when the Raspberry Pi runs, we'll find out the current draw on the multimeter. So as soon as I turn on, you can see that the current draw has gone up. This is about a medium volume. So let us start taking apart the speaker. So to start with, the battery in the bottom. So if you can see, this battery is rated for 800 milliamps. So this is why I tested the current draw for the Raspberry Pi system. Actually, you can see as to how compact the system is. This easily fits inside there. And if you give a suitable padding, you won't even feel the presence of the Raspberry Pi 0 board here. So all that is left now is to put together the system. So what I have actually done here is I have taken out the ground and the 5 volt wire out of the amplifier board, and then I have got the SCL and TX wires as well. So the SCL will be connected to a push button switch, a momentary push button switch, which when pressed will turn on and turn off the Raspberry Pi. The TX wire is for attaching a status LED or a Raspberry Pi power on LED. So if the Raspberry Pi is turned on, you will have the LED connected to the TX pin turned on, and if it is not working or if the Raspberry Pi is shut down, the LED connected to the TX pin will be turned off. This means that it is getting charged. So already I have turned on the system. So right now you can turn on the Raspberry Pi by pressing the push button at the back. But if you see the activity LED just blinked once and it doesn't stay turned on by default. For it to stay turned on, you need to enable the serial interface within the Raspberry Pi config. And in regards to the button, as it is, the button can be used to turn on the Raspberry Pi, but by default it doesn't have any programs to shut down the Raspberry Pi. So let me just show you as to what you need to do in order to have the activity LED turned on and also shut down the Raspberry Pi using the push button switch. Over to the on-screen instructions now.
So just like in the previous case, I have enclosed a text file which you can refer to set up the push button as a switch to the Raspberry Pi. So before that, we need to SSH into the Raspberry Pi. So first we'll set the activity LED to be turned on when the Raspberry Pi is on and be turned off when the Raspberry Pi is off. So to do that, go into sudo raspi config. In some versions, the serial option will be in advanced options, and in some cases it will be in under interfacing options. Go into P6 serial, enable or disable, choose yes, finish, choose yes. You can copy paste the commands one by one to get the push button switch working. So the first step to get the push button working is to install the dependencies and then later create a script which runs in the background. So you can just copy paste the commands one by one. So now all the dependencies have been installed. So what is left is just to create a script, save the script, and run the script every time the Raspberry Pi boots. So now we need to create a directory to store the scripts. We have called our script as shutdown.py since it is a Python code. Just copy and paste the command in the blank space. Press Ctrl X, choose yes, and enter. So now we need to restart the system and then add the script in the RC local so that it starts every time the Raspberry Pi also starts. Now at the bottom we have the Shairport-Sync which we added in order to start the Shairport service every time the Raspberry Pi boots. Now in order to enable the running of the shutdown by script, copy and paste the script. Press Ctrl X, choose Y, and enter. So let me now just shut down the system, and then we'll boot the Raspberry Pi by pressing the push button, and then shut it down again by pressing the push button.
So as you can see, the Pi is not running right now. The activity LED is not turned on. So let me turn on the Pi by pressing the push button. Now let me try and play some music through the Airplay or the Shairport-Sync. So that is it, guys. So the Shairport is working. So is the activity LED and the push button. So now let me shut down the Pi by pressing the push button. So as you can see, the Pi shut down after pressing the push button. So that is it, guys. With that, we have this portable Airplay speaker, fully functional and ready to rock. So I hope you like this project, and please subscribe for more such videos. Thank you.